this is going to be the funnest part of your of the 2 days that you're here, because you're going to get to, as these folks are going to be going through the progress that they've been making, you're going to see all the hardware and the testing and all the work that we're doing as we're kind of moving into this final stage as we're working together and getting vehicles ready for test flights and then eventually our crewed missions to the International Space Station. So I'm going to talk a little bit about the program, overall program, and then make way for them to be able to talk about all the progress that they've been making over these last, 3 years now, as after we awarded the contract. So you can't start a presentation like this without having a video, so we'll start next slide. So I think my favorite part of that video is it's showing, real hardware, all the work that we're doing. It's really an amazing thing. I want to kind of reinforce again that the Commercial Crew Program is really the first human spaceflight program, thank you, where we have two purposes, public purpose, and with that public purpose, we honestly get to have the benefit of not only working with Boeing and SpaceX, but also with Sierra Nevada and Blue Origin, and really supporting this development with industry to help to pursue non-NASA markets for commercial human space transportation. So it's this balancing of the NASA requirements with also enabling crew transportation capabilities that are potentially out there for the public service. But what we are working on right now is making sure that we have safe, reliable crew transportation capability to be able to provide crew rotation services for our International Space Station astronauts. The Commercial Crew Program is part of the overall NASA exploration goal, and so really this first phase of making sure that we can provide crew transportation services for LEO and ISS is really a critical portion of our overall exploration goals. I'm going to talk a little bit because the next 30, 40 minutes are going to be about all the work that they're doing. But for us to be able to establish this, the public purpose and the NASA purpose, we really had to kind of have a collaborative and purposeful stepping through an establishment of what does how do you get a NASA service along with enabling commercial space? And so I'm going to talk a little bit about all the work that we've had to do to be able to lay the framework for a commercial crewed services. So one of the key things, and I was happy to follow George today because one of the big aspects, and it's not that obvious, is we had to make a decision about were we going to do FAA licensing for our crewed missions. And by doing the FAA licensing, what it did was it really established the beginning of us developing this government commercial framework for these providers to be able to eventually, at some point, be able to have licensed missions on their own, independent of NASA capabilities. So working through that, we had to develop a memorandum of understanding. We had to work through how you establish the legal and liability framework for this work. How do you fit a government astronaut into the ability for them to be able to potentially have passengers in the future. And then how do you work licensing with a NASA crew member? We had to work through all that, laying the framework for us to be able to have licensing on these missions. In addition, we've had to work through how do you ensure that we have the ability to get the priority and the spectrum we need for our NASA communication requirements. And so we've had to obviously needed to partner with the FCC and the NTIA and the DoD on how to ensure that we can work priorities for these commercial missions. And then working with the Air Force in the Eastern Range on how you work through priorities and make sure that government goals are met while ensuring that the range has their needs met, and establishing the framework, once again, for how these commercial missions will be executed. In addition, along with the crew transportation systems getting ready, obviously there's been a whole lot of work on station. Station's been working to put up 2 docking adapters and a whole new communication system to be able to support docking with the International Space Station. I think, there's been a tremendous amount of work on planning, first developing the docking systems and the comm systems by the International Space Station program, but then going and making sure that the systems are installed and working on the International Space Station. So a huge effort by the ISS program. And then in addition, the way these missions have to fit in with the station mission has been a tremendous amount of work also. Anyone that's seen a flight planning, the logistics chart that you have realizes that it's a huge challenge to be able to handle the timing of these missions coming in and working through all the crew training templates and timelines. And so, we've been working to figure out how to do joint mission planning together, ensuring that the providers are able to own their commercial mission, but making sure that they're able to work with the station program in a joint operations fashion. And that's going to be critical for us as we're working into eventually the flight phase and how we go through all the planning and then decision making before the mission and during the mission. And then working through manifest planning and all the work that's needed to establish crew rescue capabilities and water rescue training and everything else. Just on all these fronts, we've been having to work through it. And then obviously the hardware, and you're going to have the experts here talking about this in a few minutes. I think one of the critical things that NASA had done early on as they were planning and working through a strategy on how do you get our crew members ready while making sure that our commercial providers have a consistent interface from a crew perspective as they're working through their development phases. And so we actually assigned 4 U.S. astronauts, I think almost 3 years ago now, as our crew cadre, and we established that out of those 4, we would then assign those crew members for the crewed flight tests the providers had. And so that we call them the cadre. That crew cadre has been working with providers as they have been working to develop their spacecraft systems, and it allowed them then too to have a pool to be able to size their suits and do the logistics planning to be able to have the suits and the systems ready for those crewed flight tests. We chose the flight operations director chose very experienced veteran astronauts that were able to work side by side with the commercial providers and ensure that that all their data and all the information they have from their obviously their flight experience and is provided to the providers, and then also ensures that there's communication back through the crew office too on the progress that they're making. So I think the cadre, Bob Benkin, Eric Bowe, Doug Hurley, and Sonny Williams are a cadre, and I think they've been doing a tremendous job providing that crew interface for these commercial providers. Finally, I think we always talk about what needs to get finished, or what's ahead of us, and we forget about all the work that's been behind us. And so I kind of, this is a chart that Bob Cabana, the KSC Center Director, uses, and to kind of show the accomplishments over the year, what were the goals and what's been accomplished. And we got the big stuff coming up. This is going to be a tremendous year, but we are actively checking off the items on our list and making progress for both our uncrewed, crewed flight tests and moving into our PCM missions. So with that, I'm going to first turn it over to John, and you can talk about the Boeing system.
All right. Hey, thanks, Kathy. Thanks for your leadership on the program, and Pat, who snuck out on us another First Cast conference. Let's see if we can get to my charts. All right, very good, thanks. So four major program segments. First is the spacecraft. It's actually a two-piece spacecraft, reusable crew module, disposable service module that has the propulsion system for abort, on orbit, and then through the deorbit burn. Spacecraft will land on land in one of 5 areas of the western United States, 2 of them right here in New Mexico. They're a combination of parachutes and airbags. So the good news is the design is completed, and all of the flight spacecraft are in build. We've got 30 components that need to go into their final certification testing, so nearing the end of that. So it's really good to see a lot of the spacecraft design and build get into the rearview mirror as the risk is significantly reduced. And moving into verification, we've got over 200 verifications that have now been completed and turned over to NASA. Moving on to the launch vehicle, so we use the Atlas V 422 configuration. So 73 launches, 100% mission success, chosen because unparalleled schedule and mission reliability, and a lot of work getting ready to launch humans from LC-41. So the crew access tower is done, and the orbital flight test, which will be our first launch on an Atlas V, significant progress on build of the elements of that launch vehicle. Of course, with our system, we're partnering back with NASA for the plan, train, fly portion of the mission. So all of the training aids now have been delivered. First integrated simulation has been done. So we're into now active crew training, getting ready for the first launches this year. And then ground processing out in Florida, where we do the assembly, integration, and test. So moving from segments into activity. So I did mention that crew modules are in build. We'll talk a little bit more about the spacecraft. Significant focus on integrated systems testing most of this year and moving on until about the middle of next year. So spacecraft build, we'll talk more about that. Out at Langley Research Center, we've got 5 more called land landing drop tests, where we're measuring or verifying that the landing airbags will sufficiently mitigate loads onto the crew. So in this test series now, we've got anthropomorphic test dummies. You can see one of those over on the right-hand side, but 5 more drops to go. All the loads on the crew are good. The picture on the right with the crash dummy was actually some single-seat drop tests we did in a number of nominal and off-nominal failure cases to verify that all of the loads on the crew were within tolerance. I mentioned that we're into training. We'll have another chart, but both part test trainers and the full integrated mission simulator are now actively being used, getting ready to flight. And then, integration, back with the Commercial Crew Office with the International Space Station, and really the testament to that is where are you in verification space? So having 2 of the 800 verifications already completed is significant. So looking at the spacecraft build, so a number of different orbital and test spacecraft. So first structural test article, that was completed last year. It's in the middle of about 11-month campaign where we're testing all of the different loads on the crew module and service module, and then integrated with the launch vehicle adapter. So doing structural load tests on all the different configurations. We'll do modal. We test all of the ordnance systems, and then the ordnance of all the separation planes. So we're halfway through that test series, and it will end in the middle of next year. Service module hot fire. So the service module hot fire, we built up a full flight service module. It's been delivered out to White Sands Test Facility, is gearing up initially for cold flow testing, and then in the December timeframe, we'll go through about a month of hot fire tests, testing the on-orbit, pad abort, and then the deorbit burn. So all propulsion test segments tested here in the next several months out of White Sands. From a flight perspective, we've got the 3 service modules for pad abort, orbital flight test, and crewed flight test in different semblance of build. Moving over to the right-hand side on the pad abort. So spacecraft 1 is our pad abort test article. It's nearing the completion of its build, and in the next 30 days, we'll get into the ground verification testing. So part of our verification space is running that first spacecraft through a number of verifications to validate all of the crew module systems. Spacecraft 2, I'll jump to the bottom. Spacecraft 2 will be for the crewed flight test, which will happen late next year. That spacecraft, it's a little bit out of sequence because that spacecraft has gotten through its proof test. It'll go into outfitting in the next couple of weeks. Once we finish the build on that, we're actually going to ship it out to El Segundo. It's going to go in the environmental chamber. We'll do EMI, EMC testing. It'll go through thermal vacs, acoustic, and then come back here, be checked out, and it'll be used for the crewed flight test. Spacecraft 3 in the middle is for the orbital flight test, so the uncrewed flight test, which will be the third quarter of next year. All of the big bone pieces of the structure have been built. It'll be proof tested next month, get into outfitting, and then it will go straight from build right into the uncrewed flight test. So all spacecraft for the initial flights through the crewed flight test are all in different stages of build or test. I did mention a lot of work going on the launch vehicle side. So pictures on the left, the upper picture is the Centaur tank for the uncrewed flight test. Bottom are the RP and the LOX tank, the core stage for that launch vehicle. You can see pictures of the crew access arm, the crew access tower, and then still one of the funnest days I've had on this program, we got to ride the zip line, because the program manager does need to verify that all systems are good, but incredible ride down that zip line. And then testing. So, you are as good as your test program, right? So a huge focus on testing. So in the middle on the top, it's a great picture because we are now finished with all wind tunnel tests, right? That was finished. It'll be loaded in the Aero database, and GNC guys will now get to move into verification, which should be wrapping up around December. A lot of testing and a big presence here in the southern New Mexico area. So we've got a launch abort engine there testing. That one's actually out in Mojave, but we have 3 test ends out at White Sands that are testing launch abort engines, our OMAC engines, and the RCS engine. So all 3 types of propulsion engines on the service module actively in test at White Sands now. In addition, I mentioned that we had the service module that was delivered out of White Sands in test. You can see our first parachute balloon drop test in that picture on the lower left. That's actually was launched at Spaceport America. So we got another one coming up in the first week in November. So a huge presence out here in southern New Mexico. So you can see the NASA docking system there in the middle. And then over on the far side is a structural test article that was mated to the service module for the modal testing, which was recently completed. And then training. You can see the mission trainer, the integrated trainer down on the bottom, and then part task trainers. And we have a couple sills that the astronauts come in and actually train on, the suit training. And so, as I mentioned, so our first integrated sim was already completed and getting into full-scale crew training as we move along. So anyway, program has a lot of verification to go, a lot of testing to go, but a lot of risk now is in the rearview mirror. And we got plans laid out to, as I mentioned, uncrewed flight test in third quarter and then crewed flight test in the fourth quarter, and moving through the integration and verification with NASA. And I might have a video.
nice is there was the only part of that was a drawing was, or a cartoon was the end, and I'm really looking forward to when that last part will be real too, right? So it's good. It's really, really cool to see all the work the Boeing guys have been doing. Okay, Benji, get to talk about SpaceX.
Okay, so I'm Benji Reed. I'm the Director of Commercial Crew Mission Management at SpaceX, and thank you for having me here. It's a pleasure always. I love the conference. Thank you, Pat, and of course, Kathy and John. It's always great to be up here, part of the trio. So, and that was a great video. So, let's jump in, see where we're at SpaceX. Okay, I always like to start with kind of a quick overview primer, remind us of how the whole program is put together and kind of what we're doing from our perspective. So fundamentally, we're developing a safe and reliable, complete crew transportation system, or a CTS, certified to fly humans. All of the key elements have to be certified. And so this is a really important point. And I think it's part of the thing that it's sort of the evolution from, say, the cargo programs as well. Because we have to do a full certification, not only on the Dragon vehicle and its ability to interact with station, but also, of course, on the Falcon 9 as a launch vehicle, all of our ground systems, all of our operations, and the operations run the gamut, right? Ground, launch, mission, crew, and recovery. We also have developed the Crew Dragon. It's the new Dragon 2 line, and it's the Crew Dragon that will have, of course, the Super Dracos. It has the regular Dracos, the in-space thrusters. It also has the Super Draco thrusters that are used for abort cases, both pad abort and in-flight abort cases. And then overall, the big picture that I'm always driving our teams towards, and Kathy's always reminding us all of as well, is we've got missions coming up. And so what do those look like? And so the first one is our Demonstration 1 mission. That's going to go to ISS. That will be without crew. We have the in-flight abort test. So we've already done our pad abort test a couple years ago. And that's where we had the Dragon on the pad, and we fired the Super Dracos to demonstrate that it could safely get away from the pad if something went wrong. We'll be doing, after the Demo 1 test, uncrewed flight, we'll then go and do the in-flight abort test, where we put Dragon on top of a rocket, launch the rocket, and get essentially up to the max dynamic pressure that we would see, and then around that point, abort Dragon and make sure that it could also get off and get everybody back safely to the ground. After we get done with in-flight abort, we'll move into the Demonstration 2 test, and that'll be the first test with crew on it. Both of those tests will go to the station. Both will be similar in a lot of ways, but the big difference will be Demo 2, of course, will have the crew on it. And we'll be carrying 2 of the 4 cadre that Kathy were talking about on that flight. Immediately after that, we'll step into the operational missions and start providing crew rotational services for station, which is all of our ultimate customer and you know, the real key part of this. So it's super important that we are developing this safe system for the crew and also a reliable system. And part of that reliability is that ability to hit that cadence, key for the station to be able to plan around that and make sure that we can deliver crews safely there on a certain schedule, and then of course bring them home and have the next set go up. So that's the big picture of the program. Talk about our system architecture a little bit, kind of remind ourselves of what it looks like, and this will be very similar. This is similar to what we do, of course, on our cargo missions right now with Station on the CRS program, and will continue to be as we expand into using our Dragon 2 capsule for the cargo missions as well, to create the Cargo Dragon for that at that time as well. So there's the spacecraft segment up at the top, you can see there. Of course, it's got the Dragon, which is the spacecraft, the crew module, or the pressure section, which is the top part of the cone of the capsule. And then kind of around, which forms the skirt or the base of the cone, is the service section that sees the vacuum of space. And that has all of the important avionics and tanks and propulsion system and a whole bunch of the service elements of the spacecraft. And then the trunk, and in this view you can see the trunk is below Dragon, between Dragon and the Falcon 9, and that trunk has, you can see the aerodynamic stability fins on it, and so it's different. We don't have fins on the current trunk. Those will help out during our abort cases. And of course, the other thing, as I already mentioned, if you look at Dragon, there are the Super Dracos, and you can kind of see them If you look at the base of the cone of Dragon and the base of the capsule, kind of the little black cutouts, that's actually where there are a pair of Super Dracos in each of those locations around Dragon. Launch segment, of course, is Falcon 9, the same fundamental Falcon 9 that we're flying for all customers is a really important part of that heritage, part of that safety and reliability that we will be providing for the astronauts and the crew. 9 engines on the first stage and a vacuum engine on the second stage, LOX RP1, and landing legs, of course, as we return vehicles, landing legs stowed in ascent as part of a secondary part of the mission. Primary mission always will be crew safety and timely arrival. Ground and operations segment, same sort of thing, of course. We're certifying all of those. We'll be flying out of 39A using both of our launch control systems down at facilities down at the Cape and also in Hawthorne. And then, of course, all of our different ops groups that work together and work closely with NASA to achieve these missions. Let's talk about what we've been doing recently. It's been busy since we've been here a year ago at the conference. We've got Dragons galore, Dragons all over the place. We've got Dragon capsules in work for all of the missions upcoming. Demo 1, so we actually have a qualification capsule that we've built. We had built an ECLSS environmental control and life support system capsule that we did a full-up test on. We also have Dragons in work, of course, for the Demo 1 mission and the Demo 2 mission. And we now have Dragons in work for our Crew 1, what we call our Crew 1, the first operational mission, and Crew 2, our second operational mission. So Dragons are being built for those missions as we speak. The big exciting news that just happened recently was we moved through a major milestone, which is called Integration Mate on Demo 1. So I talked a little bit before, and if you look at the pictures and you look to the right-hand column, the middle column, you can get a sense of what the pressure vessel looks like on Dragon. It's the kind of gray shape. Oops, I'm dropping my microphone, I think. It's kind of that gray shape that's inside of that structure of aluminum that you see around it, that big jig there. That's the pressure section, and so that's an entire part of Dragon. That's the part that holds the pressure. Obviously, it's called the pressure section, and a lot of work goes into that. That's the interior. That's where the astronauts will be. You can see a window there facing on it. Okay, then around that bottom skirt is the service section, and again, as I mentioned, the service section contains all of the avionics and the Dracos, the Super Dracos, all the thrusters, all that stuff is in there. So what we do is we build both of these parts up in parallel. And we've learned a lot as we've been working on the current Cargo Dragon line, learned a lot about how to improve that process and what to do. And we've applied all of those lessons to this line of Dragons. And so it was a very important milestone that we came to just in the last month, where we brought the two pieces together. So we've been building up all of these work in parallel, and without a lot of match drilling. And of course, a lot of problems that we talk about in aerospace is the artisanal craftsmanship that you have to do. You do a lot of match drilling, a lot of hand building, if you will. What we want to do is we want to build spaceships in a way that you can just put the pieces together in parallel and then integrate them all, and they all just come together and the bolts all fit. And that's what happened. On Demo 1, we were able to bring the pressure section and the service section, integrate them together. That's called Integration Mate, and all the bolts go in, and it works really well. And so we got through that major milestone on the path towards Demo 1, because after that is where you start to put on the panels, thermal protection, and off you go. You've got a capsule. We also completed in the bottom right-hand corner the major structural qualification for Dragon. That was that capsule there. You can see that with a lot of the panels on it. Other things that we've been doing, the initial crew configuration Falcon 9s are in fabrication. Again, it will be our line of Falcon 9s that we use for customers. We expect to see that kind of heritage applied for crew, and we've already started those initial builds. The crew configuration Merlin engine development testing is complete. The Dragon flight engines have completed acceptance testing, or completing, or going through a number of ship sets of those have been going through acceptance testing. You can see that up in the upper left-hand corner picture. Ongoing 39A use, I'm pretty sure I think we're up to 11 flights out of 39A now, which is fantastic. And again, just continued use of that launch pad as which we'll drive towards launching crew from, ongoing parachute testing, and then lots of hardware-in-the-loop testing. We've been bringing up additional hardware-in-the-loop test beds. You can see that picture in the bottom left-hand corner, and we're actively testing flight software on those beds. The other exciting work that we've been doing and very focused on, the new aspects of what is this crew program. It's all about the crew. And so crew-in-the-loop testing has been ongoing. You can see that in the upper right-hand corner, an example of one of those tests, mini tests where the crew comes out regularly, the cadre come out regularly to the facility and join us for a variety of different kinds of tests and validations and get their input and feedback and work with them closely as we continue through the process. Spacesuit testing is ongoing. I think most of you are aware that we released a couple of photos of the spacesuit, and they're both here. And we've been doing quite a bit of work with the crew in those suits, pressure testing, and also mobility testing and a number of other things we've been doing there. In the bottom left-hand corner, you can see an image where we were doing a lot of work, multi-agency work, both with the DoD and NASA, in doing emergency recovery testing using the DET-3 group, Detachment 3, that is there in case there's an off-nominal landing. What do we do? How do we go save the crew? So we've started doing a lot of that training as well as validation testing with the crew and in suits as well. A number of tests that were done with that same capsule that you see in that picture there. And we've continued our crew display development and integration for the crew and have moved into a number of joint NASA and SpaceX sims, which is a key milestone as we move towards flight. Upcoming, we have our ongoing integration. I talked about all those capsules, and they're all on the way. And that needs to get done here in the next year, of course, as we move towards those missions. Merlin engine qualification, we completed the development testing. We've already begun the qualification testing for the final crew version of the Merlin engine. That's in progress. Integrated systems review, we have a major review coming up where we'll be doing an integrated systems review to make sure that we're clear on how everything all works together. 39A pad modifications, we'll be adding the crew arm, access arm before Demo 1. And some lightning mitigation fixtures. Also, Dragon propulsion system will move into final testing. You can see in the upper right-hand corner a great picture of a Super Draco test happening down at our Texas facility. We'll continue that kind of testing into the next year. Parachute testing, we'll be completing that work over the next year in preparation for the initial demo flights. And then, of course, we move into the missions, which we're excited about. And we look forward to completing those Demo 1 in-flight abort and Demo 2, and the initial operational missions are targeted is to complete all of those next year. And I think that's it.
Okay.
Do you have any questions to pose to your panelists? We've got a couple from the audience here, but you have
We'll
the floor
start there, and then we'll see how I'll mix them up while the hard ones that I have.
Sounds good. So these are primarily for John and Benji, but please chime in. Of course, we want to hear your perspectives on these. So the first one is for Benji. So obviously, Elon made a big presentation down at the IAC in Adelaide a couple of weeks ago. So now with such a challenging date that he has posed for that, plus you're juggling this, is there going to be a shift in focus? How do you juggle the two programs?
Oh, that's a great question. The number one priority for the company is safe and reliable crew transportation for NASA. And of course, we have a number of customers, and we continue to service their needs all the time as well. So while we have many ambitions and goals, we always juggle those priorities and make sure that we stay focused on crew and crew safety and reliability.
Okay, great. So this is for both of you. For John and for Benji. So are these projects profitable for Boeing and SpaceX on a standalone basis, or will the return come from private future demand? I know there was some talk about putting tourists on and some other ways of funding the program.
Go ahead, Benji.
I know.
Thanks, John. Thought it was your turn. You know, I think the great thing about, and that's sort of the purpose, right, of the Commercial Crew Program is to bring about more commercial space and to really continue to help us open the space age. And I think that's what's exciting. And so I think we need to continue in that path. You know, in terms of how this all works for the company, it's a critical piece of what we're doing, and we're excited to be a part of it, and we look forward to being able to see what else comes after this.
Yeah, you know, right now we're in the middle of the development phase. So if you look at the program as a whole and through the first 6 flights, you know, absolutely. So it's going to be important for the company to have a mild return, and so we'll get there. But you know, as you mentioned too, when you start looking at opening up the market and adding destinations and adding different paying passengers, besides the flagship customer that you have, I mean, that's where, you know, the market really becomes, I think, exciting and profitable.
And I just want to add, you know, one of our goals, and it's been, we're still trying to figure out how to maximize use of these systems too, right? And so I think one of the big goals from a NASA perspective, I think we really thought about it when we set up the contracts, that the contracts allow use of these missions by both providers. Obviously, you know, NASA has to kind of agree, and we have to work it in with our goals. But the ability is there for them to be able to leverage these missions and obviously this capability for other uses too. So it goes back to kind of the 2 purposes, and how does this fit into our overall goals? You know, we have the 2 purposes, but we also have how does this also fit into the exploration goal, and then the overall kind of policies that, you know, as George talked about today. You know, there's obviously a big push from an administration standpoint about how do we not only conduct the missions we have, but also do it in a way that enhances our commercial industry. So more to come. You know, we're still figuring this out.
Well, sorry, go ahead.
No, go ahead.
I was going to say, on that note, obviously NASA has the Next Step program. To what extent have you personally or your team has been involved in helping to shape that based on your lessons learned, but also how, given your knowledge of these 2 programs, as well that of Blue and Sierra Nevada, in shaping that program?
So really, I think at the, obviously we're always sharing our, you know, what we've gained out of these pieces. And then from a headquarters policy level, they're always kind of keeping it in mind with the rest of the activities that are going on.
Switching gears slightly, so actually Kathy, I'm gonna ask you this question first, and then I'd like to see how it aligns or doesn't with SpaceX and Boeing here. But given where both teams stand on the development, where do you think NASA's had to support their development more than you anticipated going into the program from a technical perspective? Unanticipated challenges.
Actually, I think that's a really tough question to answer. I think going into it, actually, I think both NASA, we've both learned from the challenges that they're going through. I think that I always tell everybody that I think the people in the Commercial Crew Program are like gold for the rest of NASA, because the folks that work in my program have to work the technical challenges, not only with Boeing and SpaceX, but also with Sierra and Blue. And everybody's got their own unique challenges. And honestly, I kind of feel like watching how both these companies have looked at and addressed their challenges has honestly made the folks in my program better, I think, NASA engineers and providers. Obviously, we come in with our experience base, but I think the best thing we can do is not let that experience base necessarily drive their implementation. So that's been a huge learning event too from a NASA perspective.
John, areas of technical challenges that maybe you didn't anticipate as much and that you're seeing percolate, and where have you been leaning on NASA a little bit more than you anticipated?
Yeah, you know, and I don't think it was, certainly we've seen a number of technical challenges, right? And but we're in the phase of the program where you expect to see it, large-scale integrated testing. The good thing from us is we had NASA engaged and embedded in our team from the very beginning, right? So we went through all of these together, right? And so their partnership has been embedded with us from day one. So I don't think there was any particular area where we couldn't find the expertise. I think NASA augmented the expertise as we went along. I think the biggest thing for us is the teams learning to work together in a different kind of a development environment, right? So it wasn't your traditional cost plus NASA-owned design, right? So they had to embed themselves and get comfortable from an insight and verification standpoint without that design ownership. So I mean, I think they've done really well and leaned forward.
Benji?
Ditto. Good, John. No, I think it's really well said, though. I think that fundamentally this is a new kind of way of doing the insight that is expected that NASA, it's that question of insight versus oversight and what's really the job at hand. And we've been deeply embedded and integrated with NASA since the beginning. And I think they bring a lot of augmentation, a lot of great experience that we like to have help them as we move on our path toward certification in flight.
Obviously, we're getting a service out of this, but we also realize that this is a partnership, and it's about how do we work together. We also realize that the nation's made an investment in NASA for the last 50 years, and so any information that we've gained should be available to any of the companies to be able to leverage off of, right? And so the big challenge has been how to give them the information we have, let them be able to leverage off of it, but yet be able to solve their problems in their own way. Great.
So going back slightly to this question of other potential customers, obviously NASA is your primary customer and should be the focus. The ISS is made of several other countries. Have you started to have conversations with other nations that might one day want to have rides up to the ISS? And have you integrated some of their needs? There was somebody who suggested that Russia might want to, we might flip the script on them and we might be taking them up to the ISS. Have you already been having those discussions?
Yeah, absolutely. Yeah. And I think it's important. And if you go look at our spacecraft design, the NASA mission is for transportation of 4 crew back and forth, right? And so our design includes a 5th seat so that we can partner with NASA for a paying passenger, right? So that's, those limited number of trips to and from the ISS, right? But for this market really to take off, right, we're going to have to work with other countries, other companies, because you need more destinations, right? So this is just the taxi to and from. So the real telling piece of market expansion is going to be additional destinations. So certainly we have teams looking and working on that. And now it's starting to be time, right? Before it wasn't time, because really you got to become real. So now that we're within a year of flying, right, now it starts becoming something that you can really go make people understand and get excited about.
As Kathy said, these are now real photographs with the exception of maybe, the final step, but that makes a good point. Benji, opening up international discussions, other customers?
Certainly, we're excited to talk to all kinds of customers and potential clients and passengers that want to go to space. The ultimate goal of making life multiplanetary means bringing lots of life, lots of people to lots of places in space. And so that's certainly within what we're looking at now.
Great. Benji, back to you for a second. Is the current plan to reuse the capsules? And if so, what are the drivers for that decision, and how far along are you in that?
So the exciting thing, of course, for capsule reuse is we saw the first Dragon reuse this year on cargo on the CRS program, which was wonderful. And that was again, a great partnership with NASA in that certification process. And so in the future, if we look to do that, say on the crew program, we would do the same sort of thing where we would want to talk about the potential for, what would that certification look like. The capsules are being built for multiple use, just like the Falcons are. So we do expect them to be reusable.
Okay, great. I want to go back to the business case question. Obviously, we're saying ISS is the current destination. We're looking for future destinations. If ISS is not continued past 2024, does the business case close?
I think like all of us, the ISS is this awesome national treasure, right? And it's something that we should value greatly, and it's really coming into its prime, has come into its prime now, and that will continue. And so I think we all hope to see a long, good life for the ISS. I think that regardless of when, as a nation, we decide to continue or discontinue that program, in the meantime, in parallel, we're already working on we as a community, we as an industry are working on all kinds of opportunities for the future. So I think the case is always there for space.
Yeah, and so from a business case, yes, I mean, it closes, but that's not why, we're not in this market for a 2024 end, right? And so, if you look at it, and when should ISS utilization be stopped, or when should that program end, right? And it really needs to be milestone-based. So if you look at the long-term needs of NASA, right, there is going to need to be low Earth orbit work from a NASA perspective over the long term, right? And you look at deep space and the progression of the development there, right? What you don't want to do is have an ISS program end mirror what happened with the space shuttle program, right? Where we ended in 2011 and it's 2017 and we're talking about regaining that domestic transportation capability, right? What you want to make sure of is that the end of ISS is milestone based and the work on the gateway. We've got routine deep space exploration missions already going, right? You don't want to have a gap. So certainly we will be okay. We'll work really hard to further the expansion of low Earth orbit and have additional destinations. But really, when you look at ISS, boy, I hate to hear the talk of a 2024 end because that doesn't support the needs of NASA.
Kathy, I see you nodding along. Is there anything you want to add to these statements?
Yeah, I mean, I think, there's goals that, obviously the agency has and from an exploration perspective. And, it'd be nice to be able to achieve those goals that were established for low Earth orbit before, we move away from the station program.
Okay. Question about your crews with the proposed launch rate. How do you plan to keep your crews up to speed and trained properly? Are you going to augment this initial team of 4 with others? How does that work, A? And B, how does that work in terms of from an individual company perspective?
So I'll talk about we're using the same kind of the process that the Flight Operations Directorate does from a NASA perspective to assign their crews. Obviously, it's a huge logistics challenge because we're going through this period where we're having to go through demonstration missions, and obviously, you're in this big integrated test campaigns that we're going through, right? And so, in a perfect world, there would be no issues. Maybe that will happen, but we tend to do tests to find out things, and so there's no such thing as you really want to make sure you have the time to be able to address any issues that you find out through testing. So the Flight Operations Director has this huge challenge of kind of having to cover all bases from a crew transportation and a crew assignment perspective. But they have a strategy, and they have a strategy for the crewed flight tests, and they have strategies for how they're assigning crews for the post-certification missions, really, based on the pace of how these vehicles are going to be ready, NASA's going to have to be pretty flexible about how those crew assignments work out. It's going to be a huge challenge for the International Space Station program, a huge challenge for the Flight Operations Directorate as we're bringing this new fleet of vehicles in. But we're also looking at a couple of different options, including doing sortie missions and other kinds of things to be able to use multiple missions, and so we'll just have to be flexible for a little bit. But ideally, we're using the same increment crew assignment eventually when we get into nominal services that we'd be doing overall.
Okay. Gentlemen, is there anything you want to add to that question?
No, if you look at the crewed flight test, right, we'll have 1 Boeing crew member, 1 NASA crew member. You move into the services flights, right? Our responsibility is training the NASA crew, right? And so the exciting thing is it's coming up pretty quick, right, with the November with a never crewed flight test, right? Your training program, which we already have outlined and in work, right? That's starts about a year out, right? So those plans are established, and we're getting into that mode now.
Ben, do you want to add something? Otherwise, I was going to interrupt.
No, huh? No, go ahead.
Okay. Well, I was going to say, so obviously we've talked about the extra seat. SpaceX has noted you're going to already some interest in people flying with you as well. How are you two going to select those non-NASA customers to fly with you? Is it highest bidder? Is it how does that work?
You know, obviously, if you're going to fly paying passengers to ISS, it's a partnership that you have with NASA, right? So there, and the other thing is, you know, we've partnered with Space Adventures, right? Who has done that work through the Russians and the Soyuz program going to ISS. So there's obviously going to be a partnership with NASA. You're going to have some protocols that you need to go through from a personnel selection, medical, and so we just need to work through that with NASA.
Does that give you pause at all, Kathy, these discussions?
No, I mean, I think this is something that we addressed as we were pulling together our procurement strategy heading into, you know, the award, the development of the procurement strategy and the contract was, how do we, along with getting the services that we need, enable potential, you know, burgeoning commercial industry, and maybe a small step, right? I think John's right. You know, we can help initially with obviously the needs that we have, and in supporting potential commercial usage of the International Space Station. But really, this is a big challenge for industry now to put together other commercial usage and destinations. We're just helping get kind of the first steps forward, right here.
Benji, do you want to add anything to that? Do you have any other details you can share with us in terms of other potential customers and how you're going about that? John did note the partnership, their partnership with Space Adventures.
Yeah, no, I mean, I think the key is really, you know, defining what is that selection process. How do you make sure people? It's not just about, you know, can you buy the ticket? It's a big deal going to space, right?
Yes.
I mean, astronauts are, you know, they're heroes for a reason. And so we do want to transition into this place where we are, you know, carrying up passengers, and everybody has a chance to go, you know, in the future. So how do we do that? And that's what we're all looking at right now as an industry.
Great. Thank you, Benji, John, Kathy. Thank you very much for your insights. A round of applause for our panel.